Hi there and welcome to Lecture 6. So today we're looking a little bit more at dplyr and we're looking at summaries and grouping. So we're going to have a look at the summarise and group by commands. And this is really where the power from that dplyr has really comes to the fore. So we're going to be using the HRC data from Horizons Regional Council. If you want the URL to read that in yourself, look back at Lecture 2. So just a reminder from last time, dplyr is basically a package which is used for data manipulation, and it consists of a set of verbs or functions that help us solve the data challenges that are the most common, that sort of always come up when we're dealing with data. So last time we looked at select to choose variables. We also looked at rename for changing the name of variables. We can reorder the columns of the data and so on with select. Filter for changing the rows. So select which observations we want to retain in the data set. Mutate for adding new variables or columns. And arrange for changing the order of the rows. And today we'll be looking at summarise, which takes multiple observations and collapses them down to a single summary. And then we will look at group by, which is really where the power comes in, which allows you to do all of the above operations operating on subgroups of the data. So you remember that last time we also introduced the pipe, which you can put in with Control-Shift-M. It's made up of the vertical bar character, which is between the backspace and enter key and the greater than sign together. And that allows us to more sort of intuitively and in a more readable fashion write our commands. So this command here can be read as take the HRC data and put it into filter such that the value is greater than 5,000. So take the HRC data and filter it such that the value is greater than 5,000. And of course that extends naturally, so this function here we can read as take the HRC data, filter where the value is bigger than 5,000, and then arrange by site and date. Okay. And just a reminder that when you are stringing multiple verbs together like this, and you've got them on separate lines, which is often a very readable way to do it, then the pipe has to be the last thing on the line. Okay, so you don't try and put the pipe as the first thing on the line because this will not work. Okay, the other advantage of the pipe that we didn't talk about last time is that the pipe gives us code completion by pressing the tab key. So for example, if we type out HRC pipe select and then SIT, short for site, and press the tab key, then it'll bring up a list of symbols starting with the characters SIT that isn't case sensitive, so it will bring up capital SIT as well as a lowercase SIT. So for example, let me just jump to RStudio so I can demonstrate this. Let's read the HRC data in, and then we'll just do that exact command. So we'll take HRC, we'll pipe select site, so I just type site, and you notice that I get a pop-up box, and it will also come when I press the tab. I can then select which one I want. So the advantage of that is it makes sure that I get the spelling correct. Okay, in particular the capitalization, which is a common mistake, of course, is using lowercase s here, where it doesn't work. If I press the tab key on that, it'll bring up a set of options. So site ID. Okay, so that's a handy feature. That only works when you've got it in a pipe, because it needs to know what the data set being fed into the select command is in order to know that it can bring up the data set names. Okay, so today we're going to be looking at summarise and group by. So we'll start with summarise, and that's for computing summary statistics across all the rows. So generally it will take a whole bunch of rows in and it will perform some computation on one or more of the columns of the data, and will return generally a single row of output. Okay, so you can use this to compute the minimum, the maximum, the mean, the counts, totals, all that sort of thing. When we do modeling, you could use this to do modeling. For example, you could fit a linear regression line and put that in your data frame as well if you want to. So this command here, again, it's using the pipe, so it's quite readable. Take the HRC data and summarize it, computing the mean. And the mean is going to be So we're going to create a new column called mean, and that's going to be equal to the mean function computed on the value column. So you can see here we've computed the mean. Okay, so if you look back at the previous lectures, we did this before, but we weren't using the pipe, but we were using the summarise command. Now you can compute multiple summaries at once. So for example, this command here is computing 6 separate summaries. So first of all, we're taking the HRC data, we're summarising it and computing the mean, which is the mean of the values, the median, which is the median of the values, the interquartile range, which is computed by the IQR function. We're also counting how many there are. So the N helper is a super common one to be able to use. Okay, it's a very handy shorthand for counting the number of rows. So count will give us the number of rows in the data set, which is 14,046. And then these last two commands, we're computing the total, which is the sum of the value. Okay, so that's the sum of the value column added up. And then the last one, we're computing the mean in a different way. So instead of using the mean function, we're computing it by hand, if you like. We're taking our total, which is being computed here, and dividing it by our count, which is here. Right, so this is the formula for the mean. Remember, we add everything up, which is done with the sum, and divide by the number of observations, which is the count. Okay, so when we do that, of course, we get the same answer. Okay, so here what we're doing when we compute mean 2 is we're actually using summaries that have been computed previously. So when the summarise command is run, it computes things as it goes. Okay. So you can create a variable in the summarise and then use it later on in the summarise, which is a kind of a handy feature. Okay, another one that's quite handy in some cases is indistinct, which counts the number of distinct values. So n counts the number of rows, indistinct, you feed it a column and it will count the number of distinct values in that column. So that's useful if you've got a bunch of duplicates that you want to ignore. Okay. Now we can use summaries so these summaries here each produce a single result. So we've got a single row. We can use summaries that produce multiple rows, such as this one here. So the quantile function by default will produce the 0th, 25th, 50th, 75th and 100th percentile or quantiles. So that's the minimum, lower quartile, median, upper quartile and maximum. So it's going to return 5 things. So you can see that it's taken the HRC data, it's summarized and computed a new column called quantile, which summarizes the value column into 5 different things. Now the problem here, of course, is we don't know what each row corresponds to unless we know how it was computed. Okay. So a slightly better way of doing this is if you do want to use summaries that return multiple results, then make sure that you label them. So in this case, I've set up a probability vector or list of numbers, if you like, which is combining 0, 0.25, 0.5, 0.75, and 1. And then I'm using that in the quantile function to make sure that I get those corresponding quantiles. Right? So the probs argument of quantile are the different probabilities that you're evaluating the quantile at. So the 0th quantile, the 25th, the 0.25 quantile, which is the 25th percentile, and so on. Right? So these are equivalent to percentiles, but they're in probabilities instead of percentages. Right? So they go from 0 to 1 rather than 0 to 100. And this then enables us to ensure that things are labelled correctly. So we can see that 155 here is the 50th percentile, which is the median. Right? Generally, it's safest to stick to summaries that just return a single value. Okay, so if I wanted to do to compute the 5-number summary like I've done here, I would typically just say the min is equal to the min of value, the max is equal to the maximum of the value, so the max function, the median equals the median of the value, the lower quartile, then I would use the quantile function, right? So I'd use quantile, value, and then 0.25 would give me the 25th quantile, and 0.75 would give me the 75th quantile, just because that's more readable. Okay, and readability is often more important when you're writing data analysis code, data wrangling code, than speed or efficiency or anything like that, right? Because the computer is fast enough. Okay, so we can allow the computer to work a bit more if it enables us in the future to work a bit less to decode our code. So we can combine the summarise, of course, with other functions, just like we could combine a range with select or filter and so on. We can combine all of these things together to allow us to do the job that we really want to do. So it's frequently the task that we'll wish to get done with a set of data will involve multiple different functions. So we perhaps need to filter, we might need to do some arranging, some summarising, some mutating and so on. All of these steps might need to be done to answer a specific question. So in this case, we're finding a summary of counts at a common swimming location in summer here in Palmerston North. Okay, so we're taking the HRC data, and the first thing we're doing is we're making the dates a bit nicer. Right, so we're taking the date variable and we're pulling out the month with labels, and we're pulling out the year. Okay. The reason I want that is I just want relatively recent years, so I want the year to be 2013 and later, and I want summer, so I want the months to be in December, January or February. And I have this particular site, so I happen to know that the site that I'm interested in looking at, where people tend to swim, is called this one here. Okay, so I looked that up on the Lawa site. I looked at the map, zoomed in, found the name of the site, okay, and pulled it out. So we're filtering down to just those qualities. So we've got E. coli counts at the site we're interested in the summertime from 2013 onwards. And then we're going to summarise those counts to find the median, right, which is a measure of centre, and the maximum, which is kind of the highest risk, if you like. And we see that the median is 104, that's quite low for E. coli, and the maximum is 9,700, which is quite high for E. coli. So it turns out that an E. coli reading of 9,700 is equivalent to a risk of around about 50% of getting sick if you swam in that river for an hour or so. Whereas an E. coli count of 104 means your risk of getting sick swimming in the river for an hour or so is actually very low. It's less than 0.1%. So if you went to the river and the count was average like this, was typical, then there would be no risk of getting sick. But if you went to the river when the E. coli count happened to be this high, then there is a risk of getting sick. Okay. So when was this high count? Okay, well, we can find that as well, of course. So we just take the previous code that we had before, that bit there, and we're just going to filter such that the counts are larger than, say, 9,000 or so in order to pull that one out. Okay, so we just add that additional filter command there. We could put that filter command in the previous one, so we could have just modified that filter command and just added a comma and then value greater than 9,000, but let's have it separate just so that we can see that it's the same code, just with a different thing. And you can see that there are two measures that are more than 9,000. Okay, the first one is in 2018, February the 13th, 2018, it measured greater than 9,700. And then again in 2020, in December the 8th, it also measured 9,700. So February 2018 and December 2020. So these are E. coli readings taken in the summer when the river generally looks like a pleasant spot for a swim. There it is there. Now I should say, if you are in Palmerston North and you wish to swim here, I would urge caution. There have been a number of people that have unfortunately lost their lives swimming here in this bit. So there's particularly the other side here, I think it's is a bit dodgy. So make sure the river is not high at all if you go swimming. Up here is where the new lookout is. So this is obviously an old photo. There's a brand new lookout here that it's just recently opened. If you're in Palmerston North and haven't been to it, I recommend it. It's on here, Ara Kotahi, the cycling and walking path that goes out to Linton. So this here is just at the end of Maxwell's line. Okay, so that's summarise. What about grouping? And this is really where dplyr comes into its own. Okay, so the group by function, we can see it in action here. What it essentially does is adds a wee tag to the data frame so that dplyr and other tools know to process that data frame from then on within group. So you can see here that I've just taken the HRC data and pulled out some columns on this side, and I've taken the same HRC data and pulled out the same columns and then just asked to group by the site ID. So you can see that the output is the same, the only difference is this line here, so that we know that this is what's called a grouped data frame. So we've grouped by site ID and it's telling us that there's 93 groups. Okay, so nothing special's been done here other than tag the data frame with a grouping variable. So the magic happens when you then try and do something with this grouped data frame, because instead of doing it all across all the rows at once, it will do it across the rows within each group. So while this line here produces a single row, take the HRC data and summarize to compute the median. Right, so that's done across all of the rows in the data set. If we first group by year, so we're going to create the year variable with a mutate. So that's pulling a year out of the date variable, and then we're grouping by year and then summarizing. Then instead of getting a single summary across all the data, we get a summary per year. So it's done the computation all at once, but within year. So it's taken all of the observations within 2006 and computed the median. All of the observations within 2007 and computed the median, and so on. Okay, so this computes summaries by group all at once. Now you can group by more than one variable, which is often useful, but when we do so, we've got to be a little bit careful about what grouping structure we have after doing various commands. So for example, when we do a summarize command over here, right, we've grouped it by year and then done the summary. You can see that in the output here, we're no longer grouped, right? So back over here, we had this extra line here telling us that we were grouped. We grouped by the year, but after the summary, you can see that the grouping has been dropped. There's no group by here. And that's because each group now corresponds to just a single row. So it doesn't make sense to group them anymore, because doing actions per group would be doing actions on a single number, which is probably not what you want in general. Okay, so what it's done is it's dropped the grouping by year when after the summary, and that typically happens. So typically when you do a summarize, it will drop a level of grouping. So you've got to be a little bit careful when you do that and you're grouping by more than one group. Okay, so let's have a look at what this does. So we are taking our HRC data, we're creating a year variable, and we're grouping by site and year, and then doing a summary. So the summary is going to be done within site and within year. So for each site and for each year, we will compute a separate summary. So you can see here in the output, we have Arafata Drain at Hoki'o Beach Road at 2006, and we've computed the median. We've also got the same site at 2007, 2008, 2009, 2010, and so on, and we've got a different median computed to each one. Okay, so this has computed the median for each year at each site. So we've got 1,258 rows corresponding to the 93 sites at different years. Notice that when it's done so, it has spat out a message which says that the summarize command has grouped the output by site and telling us how we can fix it if we want, whereas previously we'd grouped by site and year. So it's dropped the year grouping when it's done the summary. And the reason is that within site we've got multiple rows, one for each year. But within site and year we've only got one row. So it doesn't really make sense to group by site and year, because each one has only got a single observation, and typically when you've only got a single observation, you don't need to perform summaries by group anymore. So it's dropped the last grouping variable, and now we end up grouped by site. Okay, so that's important because it then affects the command that happens next. So over here we've extended this code, we're grouped by site and year, and computed the summary, the median. So there they are there. Those are the same answers that we had before. So you can see that for each site and each year, we've got a different median being computed. So you can see that this site tends to be a bit dirtier than this one in terms of it has higher E. coli counts. But then we've done a command here where we've created a new variable via mutate, which is being set to the median of our previous computed medians. So the overall column here corresponds to the median of the med column, but because we're grouped by site, it's done it by site. Right, so here we've got the median of Arawhata Drain at Hokio Beach Road in 2006, and we've got the median of Arawhata Drain at Hokio Beach Road in 2007, and so on up to 2020. If we take the median of these values, we get 540. And because we've used mutate, it's added the number 540 as a separate column. And then of course we've got a different number for Hotapu at Alabasters, 115, because 115 is the median of the yearly medians here. Okay, so the computation for overall is being done by site, and that's because it's grouped by site and not site by year. Okay, now we can ungroup to remove the grouping. So suppose that our the overall that we wanted was the overall across the entire data set, the overall median of the med column across the entire data set. So this would be the median of the median counts at each site across all of the sites and across all of the years. We first have to ungroup. Okay. The other thing is you can override it with the .groups argument. So you can, in the summarise command, it has an additional argument .groups, which you can set to various things like keep to keep the grouping, or drop one, I think, is takes the outermost one, which is the default, or you can drop them all and so on. Okay, so the thing to remember is when you're grouping by multiple things, you just have to keep in mind at which steps you're working through your code, what each of the commands are doing. And often it's best to actually split this up. So generally, I would probably actually split this up, right? I'd do my summarise there and my ungroup perhaps in order to get a data set called something like HRC by site and year, and then I would operate on that to try and keep the code readable, basically. So that's grouping and summarising. We'll see some more examples in a moment. But there's some very common grouping and summarising patterns that are done over and over, and the obvious one is counting things, right? So say you wanted to count the number of observations you have by site, then you'd need to group by site and then summarise to compute the count using n, right? You do this command here. And because this is a super common thing to do, we have the count function. So HRC count site is equivalent to group by site and then summarise, and then drop the grouping. You can also use add count for adding a count instead of summarising. So add count will add a new column and fill in the count. So for example here's the counting, right? So take the HRC data and count by site. So you can see that we have a row for each site and we have the number of observations in each row. The alternate is to add the count by site. So that so instead of summarising, that does a mutate essentially instead of a summarise. So it does a group by site and then a mutate in order to add the count as a new column. So instead of having a summary of only 93 by 2, we've got the original data and we've added the count. So here you can see I've got my 142 has been added as another column for all of the Arawhata Drain observations, because that's how many observations we have for that site. So that can be often useful for later filtering on the ones that are more than 100 or something, right? We might want to only look at sites that we've measured a whole bunch, or perhaps sites that we haven't measured very much. So we might want to add the count and then filter them out. We still want all the observations there that we can then look at. So that's what the add count function is useful for. There are a range of other helpers as well for all of the common activities. So we have slice min and slice max are useful for finding the top or bottom observations in the data. So they're equivalent to arranging the data first, either ascending or descending, and then doing a filter on the row number. Right, so here is the code that you might do if you didn't know about slice min and slice max. Right, we're taking the HRC data, we're just pulling out the site and the value, and then we're arranging it descending by value in order to find all of the big ones. Right, so they're all of the large observations, and then we just take those where the row number is less than or equal to 10. So we're just taking the top 10 rows here. So row 1, row 2, and so on up to row 10. Okay, so the equivalent is HRC, select the site and value and use slice max. So the slice max orders by value in descending order because it's max. If it was min, it would be in ascending order, and then return 10 of them. Okay, so it's a little bit of shorthand there. So instead of arrange and filter, we've got slice max. Similarly, arrange and filter where you're arranging ascending would be slice min. So to find the top 10 or the bottom 10, slice max or slice min. There's also slice in general for finding, taking rows out by row number. Slice head or slice tail takes the top or the bottom of the data set. Okay, so if you just want the top 10 rows, you'd use slice head with n equals 10. So HRC pipe slice head n equals 10 would get the top 10 rows out of that data set. So the first 10 rows, not ordered by anything, just ordered by the order that's already in the data set. You can also take random samples. So slice sample takes a random sample. So if you just want to pull out 10 random rows, HRC pipe slice sample n equals 10. So each time I write this, I'm going to get a different result. Let's jump to RStudio and demonstrate. So there we go. So we've got those 10 there on my first run. And if I run it again, I've got different observations. Right. So my first observation here was on the Ranga Taiki, and now it's on a different location. Right. Okay, and so what we'll be doing in general is putting together all of these things to answer specific questions. Okay, so we've got 4 questions here. Which are the best or worst sites on average, e.g. using the median? Which sites do we not have much data on? Which sites are the number of observations low? Which sites are new? Which sites are our observations only after a certain date? Which sites are tested infrequently? So which sites are we only sampling perhaps every 2 months instead of every month? All of these questions can be answered using just some of these our 6 verbs. I suggest you pause the video now and have a go at these yourself. Let's jump to RStudio and see if we can answer them. So which are the best or worst sites on average by median? So to do this one, we want to first of all compute the median by site. So to compute the median by site, we need to group it by site and then compute the median. So let's jump to RStudio. So we're going to take, so which are the best or worst sites by median E. coli count. Okay, so we're taking the HRC. So first compute the median count by site. So we're going to group by site. And then summarize. Perhaps we'll just use group by site instead of site ID. And we're going to summarize the median of the value. Okay, so that's computed the median for each of the sites. And now order, and now pull out the top view or bottom view. Right, so we're going to use, so we could arrange by descending median, Right, so the worst site is this one here, there's the second worst, and so on. Or we could arrange by median ascending. These would be the cleanest sites. Okay, or we could use slice min and slice max. Right, so we could use slice max. Right, so there's the 10 worst sites, and the 10 best sites. Right, slice min. So these are the best sites. Okay. What about sites we don't have much data on? So the sites that we don't have much data on are the sites that have few rows in the data set, so we could just count the rows. So if we count site, that'll have the number of rows in the data set. So we could just arrange by n, by our count, and we can see that these are the ones that we have haven't got too many measures on, so we've only got 54 at this first one out at Himatangi Beach. Okay, we could also use slice min for this, couldn't we? Right, so there's the five bottom. So this is a handy thing. So you'll notice I asked for 5 rows and it gave me 6. And the reason is that by default, when there's a tie, it will return all of them. And you can control that with slice min. So if we have a look at the help for slice min, then we can see down here, there's this with ties equals true. So if you have a look at this ties, should ties be kept together, the default true may return more rows than you request. Use false to ignore ties and return the first n rows. So if we put with ties equals false, then we'll only get 5. Okay, so it's thrown away the turatea at number 1 dairy, which is a massive farm. This is right next to the Manawatu campus, just across the road there. The Turatea stream is the one that you cycle or walk or drive over just before you turn left to come into the main Manawatu campus. And so that one goes through the number 1 dairy farm, which is between the campus and the river, and goes into the river down. There's a platform where you can feed the tuna or the eels. If you haven't been there again and you're in Palmerston North, I highly recommend it. It's right opposite, in fact, that the place where you can go, where many people go swimming, that we had a photo of before. Which sites are new? So to find the sites that are new, we might find the first date at which they were measured. Right, so we could do something like which sites are new. Find the first date where each site was sampled. Right, so we're going to go HRC, we're going to group by site. And we're going to perhaps summarize. The date will be the minimum date. Okay, so that'll be the first date at which things were measured. Okay, and then we would we want the last ones to be measured, so we're going to slice max the date, n equals 5, say. There we go. So this is the newest one here. Okay, and unsurprisingly perhaps, this corresponds to the site we haven't measured much, because it's the newest site, so we haven't had opportunity to measure it. So this is not necessarily getting at how frequently we measure. It might instead just be that we haven't had the opportunity to measure these ones very often. So we may actually be measuring them all at a similar frequency. I think the idea is that they're supposed to be sampled every month. So the last one, which sites are tested infrequently? So what we want to know here is kind of a measure of how often they're tested. So what we could do is we could take the period over which they've been testing. So we found already when each of them started being tested. We could find the endpoint as well. And we could also find the number of observations, the number of sampling occasions during that time. And if we take the length of time and divide it by the amount that we've sampled, we'll get the period of sampling. So we'll get how many days between each sample on average. So what we could do is we could take the first sampling and the second sampling and the last sampling would be the maximum of the date, and then we could also do the count. Right, so let's do that. So now we have the last time it was sampled, the first time it was sampled, and the number of samples that were taken. So if we go last minus first divided by count, so days per sample would be last minus first divided by count. Okay, so we can see here that the days per sampling differs for each site. So this one here is 51.7 days, whereas most of them are around 30. And then of course we could again slice max by days per sample. Find the top 5. So there we go. So the one we sample most infrequently is Hokio at Lake Horowhenua. Okay, which we sample only every 51 days. And the one we sample the most would be at the Tui Brewery in Mangatanoka, which we sample every 29 days. So there we go. So try and reproduce those yourselves. Obviously we have the answers. These may not be the same necessarily. I've done them with slice min and slice max and by arranging. Which sites are new? I think that's very similar to how we did it. Which sites are tested infrequently. This is similar, except instead of doing 2 summarizes, so I've computed the date range here. So we did that, didn't we? And we've computed the count, and then I've used mutate. So I've dropped it down with the summarize to those 2 summaries that we need, and then use mutate to compute the average. So you can see here that we've got the date range and the count, and then that divided by that is that. Okay. So lastly, I just wanted to do a bit of a demo using some data from Bird of the Year 2019. So this is in fact last year's contest. Dragonfly, who's a data science company in Wellington, ran Bird of the Year, or generally runs Bird of the Year, and in 2019 and 2018 I think as well, they published the data, so you could get all the data on all the counts, and this is what it looks like. So what we want to do is just have a peek at these data and see what we can come up with in terms of answering a few questions. So let's jump back into Studio. In case you're interested, I might put these up on the web. So at the moment I'm just loading them locally, but I'll put them up afterwards. So what might we do with these? So let's have a look at what this data looks like. Let's perhaps we'll use the spreadsheet view. Oh, that's the HRC data. We know that one. Here's the Bird of the Year data. So we've got 1 row per vote. And this was done with preferential voting, so single transferable vote. So you had 5 choices where you ranked, you gave your top 5 choices. So you can see here's perhaps the first vote at 8 a.m. On the 28th of October 2019, and they voted for Gibson's albatross, the tui, the kaka, the kakapo, and the little spotted kiwi. Some people you can see here only voted for 3, top 3, and didn't bother 4 and 5. There's another one. Okay, and so on. Right, so we have all of the votes in the data set. We also have the country, which is mentioned sometimes but not always. I'm not sure if we'll be able to find one where it's not empty, but we could do a filter on that, couldn't we? So what we want to know is, first of all, who won, and perhaps how the voting went over time. So let's have a play. So what we could do is we could start by looking at how the voting went over time, perhaps. So we could group by date, and perhaps, or we could just count the dates, couldn't we? That would do it. So here are the number of votes over time. So you can see on the first day there were about 4,000 votes, and then it dropped off, and then obviously there was something that reinvigorated interest. About a week later, perhaps there was a news story or something on Bird of the Year, which got a bunch more people voting until the end. So we could do a wee chart of this, I suppose, by taking our doing our count and then throwing that into geom col. So mapping would be, whoops, ggplot geom col, and our mapping would be, so we want x to be date and y to be the count, just n. Oh, I've done a plus there instead of a pipe. So there you go. You can see that that the number of votes was quite high initially, dropped off, and then it was sort of reinvigorated. Perhaps there was a news story around here, perhaps some details about who was winning or something was released, and so there was a bunch of more interest generated. We could also look at when people voted, so we could use the hour. So we could count by hour and then do the same plot. Okay, so you can see here that most voting occurred in the daytime in New Zealand. Okay, there's a bit of a drop off around, so this would be 5 o'clock, 6 o'clock, when people are organising dinner or perhaps going home from work or something. And then there's another peak sort of in the evening, and then it drops off and not much during the day, during the night, which kind of makes sense for voting that was done in New Zealand generally. However, it is something that's done on the web, so it is a website you go to vote. So we might be interested in also counting the countries. Okay, so there's a count of the country, and you can see that it's really from all over the place. So here's some from Belarus, there's 22 in Belgium, Bosnia and so on, Bulgaria even. We might want to perhaps arrange those by their count descending. So we can see that the top number of votes came from a country that was unknown. So this is a country that I guess is derived from the information that the web browser supplies to the website when it goes there. So I guess a bunch of people, it couldn't determine their country of origin. So that might have something to do with how it was voted. So this might be votes on the web versus votes on mobile, perhaps. I don't know. But then, as expected, New Zealand is the source of most of the votes. And then the UK, which kind of makes sense. There's quite a few New Zealanders in the UK. Australia, again, that makes sense. There's no doubt quite a few New Zealanders in Australia and in the US. Interestingly, the Russian Federation. I wouldn't have thought there were that many New Zealanders in Russia, but there we go. I seem to recall in one of the years, I'm not sure if it was this year, there was in fact some suggestion of vote manipulation out of Russia. perhaps not run out of Russia, but perhaps machines in Russia were used by someone in New Zealand, as presumably. The rest seem reasonably sensible. Okay. I guess we could maybe find out. Let's filter by country is equal to the Russian Federation, and then we could count by hour again and plot those. Can we sort of detect when they were done? Yeah, so here we go. So this is where you'd expect the counts to be. In New Zealand at sensible hours, but in fact they happened at 3 or 4 in the morning. So potential voter fraud here. Obviously we want to count which birds had the most votes. So this is a little bit tricky because of course it was preferential voting, right? So vote 1 would count the most. So we could count vote 1. Okay, and obviously we have 85 different birds were voted for in count 1, so here they all are. See that out of these top ones, the banded dotterel's winning, but let's look at the top 10. In the top 10 we find that the yellow-eyed penguin, or hoiho, is the number 1, with 5,757 first preference votes, followed by the kakapo, and then the banded dotterel. But of course it's a preferential vote, so vote 2 would have counted next. What about the preferential vote? In fact, the top vote 2 is actually empty. So towards the end of the competition, lots of people just voted for their favourite, and you can see that actually the person who came, the bird that came first is actually only 4th with top 2, and in fact the kakapo wins the second vote. And we could have a look at some others as well. Here's the vote 5, so we can see that the yellow-eyed penguin won the second most vote. So what we might want to do is see sort of how the voting changed over time. Did the leader change, right? Or was the yellow-eyed penguin actually in the front from the beginning, or did it change as the voting period went on, because there's 2 weeks to vote? So how might we do this? Well, we'll need to group by date. Well, first of all, we'll need to combine the votes. So what I'm going to do is we're going to pivot longer. We're going to take the columns that start with vote. We'll learn how to do this later. And we're going to go to a column called vote. And put the values in a column called bird. Starts with. There we go. So what I've done is I've taken our taken these 5 columns here with Gibson's albatross, tui, kaka, kakapo, and little spotted kiwi, and I've put them down here. So the first thing I need to do is have a voter ID, I think. Do I need a voter ID? Maybe I need a voter ID. Let's add a voter ID. So that's just going to be the row ID. I think I can just use row number. Let's have a look. My starts with is messing up, isn't it? So it's trying to combine vote 1, vote 2, vote 3, vote 4, vote 5, and voter ID, because that's what I've asked for the columns to pivot. So I'm going to change that to an underscore there. There we go. So now we've got which voter it was, which vote it was, and what the bird was. Okay. So now what I want to do is I want to count the birds by date, so that I can assess whether things are changing by time. So I'm going to group by date, and bird and summarise votes equals n. Let's have a look. So hang on a sec, let me think. Group by date. I see the problem. So problem while computing votes equals n. There we go. Right, so now we have the date and the number of votes for each bird on each date. Okay. So now, for example, so we could have votes by date. Call that, and then we could take our votes by date and we could filter out just the first date, and we could arrange by descending the number of votes. So on the first date we can see that the kakapo is winning. So on the first day of voting, kakapo was leading the yellow-eyed penguin in number of votes. Now, of course, this is the number of votes per day, so we couldn't. So while we could also do this for the second day. This is just votes on the second day. It's not the total number of votes up to that date. Okay. So what we might want to do is we may want to ungroup in order to remove the grouping by date, and then we want to group by bird, and arrange by date. So what I want to do then is within each bird I want to create a new column with a cumulative sum of votes. So what this is going to do is, so this is the votes on day 1, but the votes on day 2. So let's have a look. So now if we filter by the second date, we can see that the we can see that we've got the total number of dates, total number of votes to that date. So votes on day 2 were just over 1,000 for the kakapo, and in total they had just over 2,000. So the kakapo was still leading after 2 days. Okay. So now we might just want to know, we just might want to plot this, right? So let's throw that into ggplot. Probably use a line chart maybe. So we're going to have date on the x-axis, and we're going to have the total number of votes on the y-axis, and we're going to maybe colour it by the different birds. Way too many birds. That's not going to work. First of all, we might turn the guides off by just saying we don't want the colour guide on. There we go. Okay, so we've got way too many birds. But we can still see what's happening here. So this is interesting. We've got, here's the kakapo. And one of these ones must be the hoiho coming through at the end. And we've got a very big change in leader as we go, which is interesting. So perhaps we'll filter things down to just pick out the top few. So let's group by date, and then slice max total Okay, so now we've only got 10. So we could perhaps turn the guide back on now, so we can see which ones they are. Okay, so we seem to have the yellow-eyed penguin at the top there. NA. Of course. So that just about who won was all those people that didn't vote for a bird at one of their preferences. So we want to filter those out, of course. So we'll filter. We want the bird to be not NA. There we go. Okay. So there's a chart of the birds, top 10 birds. Notice there's more than 10 because I did the top 10 per date. Okay, so some of them stopped, for example, because they're no longer in the top 10 after a wee while. Okay, but we can see here that the kakapo was actually winning right up to the last 3 or 4 days. So the moral of the story is always remember to vote, even if it's on the last day. And I should have a wee plug here. The most important vote you'll do, other than Bird of the Year, of course, which is very important, this year, of course, is local body elections. So please do make sure you're enrolled to vote. Most of you are in a young demographic, not all of you, of course, but most of you are a lot younger than I am. And typically what we find in local body elections, so that's voting for your local council, is that only about a third of people vote that are eligible. And that's because many young people, in particular, don't bother voting. So if you as a young person votes, your vote is worth a lot, because essentially you're voting for 3 people. And the other thing that's important to remember is that the people that do vote are people like me. People who generally own their own home, are financially pretty stable, have a reasonable job, they own their own home. So these types of people like me, don't really care if more houses are built or not, because we've already got one. We don't want things to change too much, because we like things just the way they are. Now, I suspect that you probably want things to change. If you're a bit younger, you want housing to become more available, more houses to be built. And the things that really control that are not central government, but they're local government. So they're your people like your mayor and your councillors. So I strongly recommend you please do enrol to vote. If you've moved recently, make sure that you update your address so that you can receive your voting papers and can actually vote. And check out what each of the councillors that represent you stand for. So you can often find a lot of information on places like the Spin-Off, often have a survey that they mail out to all of the councillors across New Zealand, ask them a bunch of questions, and then you can see their answers. So you can do a little bit of research and find out, which ones are pro-housing, which ones are saying, yes, we need to build more housing, and which ones are saying things like, no, we need to retain heritage and character and all that things that old people like. Okay, so please do enrol to vote and vote for your future.